Greetings. A world ruled by giants. Around 66 million years ago, Earth was almost unrecognizable compared with the world we know today. There were no modern cities, no humans, no airplanes, no highways. Instead, enormous reptiles dominated many of the planet's ecosystems. Dinosaurs had existed for more than 160 million years and had survived countless environmental changes. Some were enormous plant eaters. Others were powerful predators. They lived across forests, plains, coastlines, and ancient continents. For millions of years, they appeared to be one of the most successful groups of animals Earth had ever produced. Nothing suggested that their reign was about to end. But somewhere in the darkness of space, a massive object was moving toward Earth, and nobody on the planet could see it coming. The world before the impact. The Earth of 66 million years ago was much warmer than today. Sea levels were high, and continents were arranged differently. The Atlantic Ocean was still relatively young. India was moving northward toward Asia. Large inland seas covered parts of North America. The climate supported enormous ecosystems. Dinosaurs were not the only creatures living there. Early mammals were already present. Birds were evolving. Crocodile relatives lived in rivers. Insects filled forests. The oceans contained giant marine predators. Life was everywhere. But beneath this seemingly stable world, geological changes were already taking place. Volcanoes were erupting on a massive scale. Climate conditions were shifting. Ecosystems were under pressure. Then something arrived from space. Something far more destructive than any ordinary environmental change. The object in the sky. The asteroid that struck Earth was enormous. Scientists estimate that it was roughly 10 kilometers wide, although the exact size remains uncertain. That may not sound huge compared with the planet, but an object that large traveling through space at tremendous speed carries an extraordinary amount of energy. The asteroid had probably been traveling through the solar system for millions of years. It may have originated in the asteroid belt between Mars and Jupiter. A collision or gravitational disturbance could have eventually changed its path. Over time, its orbit brought it into the path of Earth. There was no global warning system. No astronomers watching the sky for dangerous objects. No technology capable of stopping it. Earth was simply in the wrong place at the wrong time. The final moments. As the asteroid approached Earth, it crossed through the atmosphere at an incredible speed. The atmosphere could not stop it. The object continued downward. Below, it was a shallow sea covering what is now part of Mexico's Yucatán Peninsula. The asteroid struck. The impact was beyond anything humans have ever witnessed. The energy released was enormous. A gigantic crater formed almost instantly. Rock was shattered. Material from deep underground was thrown high into the atmosphere. A massive shockwave traveled outward. The surrounding region was devastated, and the consequences did not remain near the impact site. The entire planet was about to experience the aftermath. The crater. Today, the impact site is known as the Chicxulub crater. Most of it is hidden beneath the Yucatán Peninsula and the Gulf of Mexico. The crater is roughly 180 kilometers wide. For decades, scientists searched for evidence explaining what had happened at the end of the Cretaceous period. Then geological research revealed a remarkable pattern. A thin layer of rock dating to around 66 million years ago contains unusually high concentrations of iridium. Iridium is rare in Earth's surface rocks but more common in asteroids. This discovery became one of the major clues connecting the extinction event with an extraterrestrial impact. The crater provided another enormous piece of evidence. Together, the geological record and crater evidence transformed our understanding of the disaster. The first shockwaves. The impact would have generated devastating physical effects near the crater. A gigantic shockwave spread across the surrounding region. The ground itself was violently disturbed. The impact also produced enormous amounts of heat. Material thrown into the atmosphere began traveling around the planet. In nearby areas, the destruction would have been immediate. But the most important part of the disaster was still coming. The asteroid did not need to destroy every dinosaur directly. It only needed to change the environment enough to make survival extremely difficult. The real catastrophe was going to happen in the atmosphere. Fire across the world. Scientists believe material ejected by the impact re-entered the atmosphere. As particles and debris fell back toward Earth, they released enormous amounts of heat. This contributed to widespread fires. Forests burned across large regions. The exact scale and timing of these fires remain subjects of scientific research, but evidence from around the world shows that the impact caused an extraordinary environmental disturbance. The planet was no longer the stable world that dinosaurs had known. The skies changed. The atmosphere filled with dust and aerosols. Sunlight was reduced, and the food chains that supported entire ecosystems began to collapse. The darkened sky. Perhaps the most important long-term consequence was the dramatic reduction of sunlight. Dust, soot, and sulfur-containing material entered the atmosphere. Sunlight struggled to reach Earth's surface. Temperatures fell. Photosynthesis was severely disrupted. Plants depend on sunlight. Without enough sunlight, plants cannot grow normally. And when plants decline, herbivores suffer. When herbivores disappear, predators suffer. The effects move upward through the entire food chain. This is why the extinction was not simply a story about an asteroid hitting Earth. It was a story about an entire planetary system being disrupted. The collapse of food chains. Imagine a world where plants suddenly become difficult to grow. Large herbivores would have enormous problems finding enough food. Their populations would decline. Predators dependent on those herbivores would then face starvation. Aquatic ecosystems were also affected. Marine food chains depend heavily on microscopic organisms. When sunlight decreases and environmental conditions change, those organisms can decline. The result is a chain reaction. One species disappears, then another, then another. Not every organism disappears at the same time. Instead, ecosystems slowly become less capable of supporting the enormous variety of life that existed before the impact. The end of the dinosaurs. The non-avian dinosaurs eventually disappeared. This includes the famous groups we recognize from fossils: tyrannosaurs, triceratops, hadrosaurs, ankylosaurs, and many others. But there is an important scientific detail. Not all dinosaurs disappeared. Modern birds are descendants of dinosaurs. That means dinosaurs did not completely vanish. One branch survived. Small, bird-like dinosaurs were better positioned to survive the changing environment. Their descendants eventually diversified into the enormous variety of birds living today. So when we see a bird flying across the sky, we are looking at a surviving branch of the dinosaur family tree. The survivors. The extinction event was devastating, but some groups survived. Small mammals survived. Birds survived. Crocodilians survived. Turtles survived. Some amphibians survived. Many insects survived. Certain marine organisms also survived. Size may have played an important role. Smaller animals generally require less food. Some could shelter underground. Others could survive on seeds, insects, or food resources that remained available after plant communities collapsed. The survivors were not necessarily the strongest animals. They were often the ones whose biology allowed them to survive a drastically changed environment. Volcanoes and a changing planet. The asteroid was not the only major environmental event occurring around this time. In what is now India, enormous volcanic eruptions created the Deccan Traps. These eruptions released huge quantities of gases into the atmosphere over an extended period. Scientists continue to study how much these eruptions contributed to environmental stress before and after the asteroid impact. The important point is that Earth was already experiencing major geological activity. The asteroid arrived during a period of significant environmental change. However, the Chicxulub impact is widely regarded as the primary trigger for the mass extinction at the end of the Cretaceous. The combination of evidence is what makes this extinction event so scientifically important. The world after the extinction. After the extinction, Earth entered a new chapter. The great ecosystems dominated by non-avian dinosaurs were gone. Many ecological niches were suddenly empty, and evolution began filling them. Mammals diversified. New predators appeared. New herbivores evolved. Forests changed. Birds diversified. Over millions of years, the planet developed ecosystems very different from those that existed before the impact. Eventually, one group of mammals would become particularly important. Primates evolved. Much later, humans appeared. Our existence was not inevitable. It was the result of millions of years of evolutionary history following countless changes to Earth's ecosystems. How we know what happened. The story of the asteroid is not based on one fossil or one scientific theory. Scientists have gathered evidence from many places. There is the Chicxulub crater. There is the global iridium-rich layer. There are shock minerals created by extreme pressure. There are fossil records showing a major extinction around the same time. There are chemical signatures preserved in rocks. There are changes in ecosystems visible across geological layers. Together, these clues form a scientific picture of the event. We cannot travel back 66 million years, but rocks preserve evidence. And by studying those rocks, scientists can reconstruct events that happened long before humans existed. Could it happen again? The asteroid that ended the age of non-avian dinosaurs is ancient history. But asteroid impacts are not purely fictional. Objects still travel through our solar system. The important difference is that modern humanity has something dinosaurs never had: the ability to observe the sky. Astronomers track near-Earth objects. Scientists calculate their orbits. Space agencies develop planetary defense technologies. In 2022, NASA's DART mission demonstrated that a spacecraft could deliberately change the motion of an asteroid moonlet. That was an important demonstration of planetary defense technology. It does not mean humanity is completely protected from every possible asteroid, but it proves something remarkable. For the first time in Earth's history, one species has the technology to detect certain cosmic threats and potentially do something about them. The dinosaurs never had that opportunity. They simply looked up at a sky that gave no warning. And one day, without understanding why, their world changed forever.